Okay, so welcome to Algebra 2 Trig. And we're going to start out the first day, this first video, solving some equations. So this is Chapter 1, Day 1. Make sure in your notes you have that headed like that on a separate sheet of paper. Today's focus question is, how do we solve absolute value equations and inequalities? Okay, and so absolute value, if you remember from earlier years in math, is notated by this vertical lines, two straight up and down lines around the problem. So instead of parentheses, we use two vertical lines, and that's absolute value. And the absolute value is the pure distance away from a number or away from zero. Okay? It's like the distance from my house to someone's house might be 3 miles no matter which way you look at it, because it's the absolute distance. This is absolute value. To solve an absolute value equation, first of all, we see it's an equation because there's an equal sign. And we go through a process, okay? In an absolute value problem, if you remember from Algebra 1, they look like a V because the Y value can never go negative if there's no negative sign out in front of this, all right? And because of that property, it heads in two directions, so we need to set up two problems. So the first thing we're going to do is we are going to set up two equations. We're going to set up two of them. The first one is just going to be the original without the two bars there. So original without the bars, without the absolute value sign. So here's our first one that we're going to set up. No different, just we took away the absolute value symbol. Okay? The second equation is going to be the original without the bars. Except now, because it can head in the other direction, we need to negate our original answer. So again, original without the bars but negate the answer. Negate the answer. Well, if the answer was initially negative, you'd make it positive. Since this is initially positive, we will make it negative. But only the answer, not the initial question. So we set up x minus 5 equals negative 3. Okay? Step 2. Solve each for x. Just go ahead and solve them. So if you remember from basic algebraic, we're going to add 5 to both sides. And x is going to equal 8. Add 5. And x will equal 2. Okay? Last thing we're going to do is we want to check our answer. Alright? So we're just going to do a little double check of our answer. And we check by substituting back into the original problem. So we take the 8, plug it in. So here's our check. I'm going to check each one. So we have 8 minus 5 equals 3. And again, that's absolute value. 8 minus 5 is 3. And the absolute value of 3 is 3. That one checks. Here's our check for this one. Plug in 2 to the original question. 2 minus 5. Absolute value of 2 take away 5. Well, 2 take away 5 is negative 3. But again, the absolute value of negative 3, that distance of negative 3, whether I'm going forward 3 or backwards 3, is a distance of 3. So what does the absolute value symbol do? It just takes away the negative sign. 3 equals 3. Check. Okay. And that's equations. set up two problems, the original, but I'm going to switch the sign on the answer, solve them both, check them. They both work, and if they both work, then I can box in my answer. Now let's take a look at inequalities. If you remember, an inequality sign are the greater than, or less than, or greater than, or less than, or less than or equal to, greater than or equal to signs. And the reason why they're called inequalities is it's not equal to specifically one number. It can be equal to many numbers, okay? So if you notice, this problem has absolute value, so I know it's an absolute value problem, but we also notice an inequality sign, okay? The first thing we have to do, though, is I don't want anything on the side of the absolute value except for the absolute value. So you see how there's a -2 here? Got to get it to the other side. When you put something by itself in the world, we call it isolating. So the first thing we're going to do is to make sure we isolate the absolute value. Get anything that's not inside the absolute value to the other side. So we're going to add 2 and 2. So absolute value 5 minus x less than or equal to 3. Now, again, because the absolute value is a v heading in two directions, we need to set up two problems. So step 2, set up two equations, or two inequalities in this case. And when you're taking notes with me, your paper should look identical to mine. We have an example, we have a problem we're working out here, we have the steps over here, and I'm going to be checking that as your homework, okay? So, set up two inequalities. Again, original without the absolute value symbol. So, and I move over just to give myself some room. 5 minus x less than or equal to 3. And we're going to change the sign on our answer. But with an inequality, we also have to switch the direction of the inequality. So, you got original without the bars, and then you have to do the original without the bars, but flip the direction. You have to flip the direction of the inequality sign. So the original without the bars, but flip the direction of the inequality sign and change the sign on the answer. Change the sign of the answer. So you have to do two things. Flip the direction and change the sign on the answer. So if I rewrite this and I flip the direction of the sign, this turns into 5 minus x greater than or equal to -3. I have to do both. I have to flip, all right? Okay, when we're talking about flipping the direction, all right, this gets flipped. From here to here. If it is equal to, the bar stays underneath it. If it was purely less than or greater than, then it's still less than or greater than. Flip, and then this sign change. Flip and change that. And then, just like before, step 3, solve each inequality. So, we solved inequalities in Algebra 1. we're going to get x by itself, get anything else to the other side, so I'm going to take away 5. So I got negative x less than or equal to negative 2. Divide by negative 1. X. Now, if I divide by a negative or multiply by a negative, remember, this has to switch again. Negative 2 divided by negative 1 is positive 2. 5 minus x greater than or equal to negative 3. Well, I'm going to take away 5. Negative x greater than or equal to negative 8. Divide by negative 1. Again, change the direction of the inequality because I'm dividing by a negative. So I get x now is less than or equal to negative 8 divided by negative 1 is 8.
If anyone's interested that was here this morning from the music department, if they'd like to come to the main office for a little bagel or donut.
Step 4, okay? Now you have to, after you've solved, you're going to write each solution in set notation. Set or interval notation. We'll do both. And I want you to graph the solution on a number line. So, again, write each solution in set or interval notation. We're going to do both. And graph on a number line, because we use both set or interval notation, because if this was multiple choice, you'd have to be able to pick out the right notation that they wrote it in, whether it's set notation or interval notation. All right. So, let's graph this. I need 2 and 8 are my important places on my graph. Make sure this is a number line. So if this was negative 8 should be on this side of 2. All right, it's positive, so I leave it over there. We go closed circle because of the equal to part. Okay. And now I want numbers that are bigger than or equal to 2. Well, that's this way. And I want numbers that are less than or equal to 8. Well, that's this way. And so in this case, the line would run between the two circles. Okay? If this was less than 2, then the arrow would go this way with an arrow on the end. And greater than would go that way with it on the end. Okay? Now, so that is how we graph it. So there's a graphical solution. Let's write it in set notation. And so for set notation, we use a bracket. And we write it this way. The variable we're talking about, which is x. Okay? So we read this as all x. That's what that stands for, all x. And then we put a little vertical line here. And this vertical line means such that. Okay. So we want all x such that. Now, if it runs between them, these are all numbers bigger than 2 and less than 8. Okay? So if it runs in between them, we need to put the x in our notation in between the two numbers in question. So all x such that x is greater than or equal to 2 and less than or equal to negative 8, and that ends our set notation. So this part here, we read x is greater than or equal to 2 and x is less than or equal to 8. Both situations occur and are fulfilled at the same time. And that is set notation, okay? This is set notation. In Math 1, you also learned about interval notation, and sometimes interval notation is also used on the test. And if you remember interval notation, if you can include and touch that number, then we use a hard bracket rather than the curvy soft bracket. 2, comma, 8, we can include the 8. So, if you just a real quick recap, use this when the number can be included. So for example, this symbol or that symbol with the equal to underneath. And then we're going to use the soft bracket when the number can't be included. Okay? When it can't be included. Or also for infinity. So for example, I might use this symbol, or I might use this symbol, or infinity, or negative infinity if I'm down under. Remember, infinity is like a sideways 8. But you need to write your solution. Now, if the arrow was going outward, then instead of the middle part, we would write the word or. Let's take a look at one. Okay? So solve and graph and use notation. So if I'm going to solve and graph and use notation on this problem, all right, so I got 2x plus 1. Oh, first thing I have to do, got to bring the 3 over. Bring that negative 3 over by adding 3 to both sides. So I have 2x plus 1 greater than or equal to 7. Set up two problems. 2x plus 1 greater than or equal to 7. 2x plus 1 less than or equal to negative 7. Remember, flip and switch the sign. Now solve them both. Take away 1. 2x greater than or equal to 6. Divided by 2. X greater than or equal to 3. Take away 1. 2x less than or equal to negative 8. Divide by 2. X less than or equal to negative 4. So now, again, we want to graph these on a number line. So I put out the two numbers in question. Negative 4, because it's lower, would go on the left. 3, higher, goes on the right. I can still fill in the circles because I have an equal to situation. If not, remember, you'd leave an open circle. Now I want numbers bigger than 3. Well, that's out this way. I want numbers less than negative 4. That's that way. So numbers in between don't work anymore. I have to pick a number up here or down here. And because of that, we write set notation this way, all x, such that we write two separate pieces. X greater than or equal to 3, or x less than or equal to negative 4. We just have to write out two separate pieces when we have two separate arrows. And you notice, or, when the oars on the boat go out, oars, you'll end up with an or in your answer. And that's how we kind of help remember that. You can't do and. I can't find a number bigger than 3 and less than negative 4 at the same time. Okay? Interval notation would look then like this. I can still touch it, so I use hard bracket, but I'm going all the way to negative infinity, so I got two separate brackets going. So negative infinity, though, is soft bracket, because it goes all the way forever negatively, all the way up to negative 4, or hard bracket on the 3, and all the way out to infinity. But infinity, you can never really touch that answer, so I soft bracket that. So that's the notes for today. When you come into class, there's going to be a warm-up question on the board for you to start on. I will be checking to make sure your notes are complete. Thank you.